All right, welcome back. This is part 3 of lesson 3.2, linear equations. So let's look at our first example here. Find the equation of the line through points 2 and 1 with a slope of 1/2. So this one's already giving us some information that we know. We already know what the slope is. Y equals 1/2 x plus b. And so now we want to solve for b. So we can take these two coordinates that we've been given and put those in for, this will be x, this will be y. So for y, we've got 1, and that equals 1/2 times 2 plus b, and we get that b is equal to 0. So y is just simply equal to 1/2 x. Okay? Or we can also say f of x is equal to 1/2 x. Okay, now let's look at a very practical application of using linear equations in a good old-fashioned physics problem. So it says here, Newton drops a stone off a 20-foot cliff into a lake. The rock hits the water 4 seconds after he releases it. So first, can you write an equation that shows the altitude, y, of the stone above the water at a given time, x, after the release? So here's a hint. You have 2 points on the graph. What are they? So we really have given you 2 points already. The first is that Newton drops a stone off a 20-foot cliff. Well, if he drops that stone right before he drops it, how much time has gone by? Well, before he drops it, the time is 0. And the height, which is y, the altitude, is 20. Okay? And then the other piece of information, so that's a coordinate. Another coordinate we have is that the rock hits the water 4 seconds after he releases it. So that's 4 seconds into the time. And what does the water represent, really? Well, that represents the end of the altitude for that rock. And so now it's at the 0 position. And what we really want is an equation that would allow us to figure out what the altitude would be at any point in between, before after he releases it and before it hits the water. So now, as usual, we can do a slope. That's going to equal 0 minus 20 over 4 minus 0, and that's going to equal -5. So in simple terms, our equation, f of x, is going to be equal to -5x plus 20. And you might be asking, well, how did he know to have plus 20? Well, because of this first coordinate, 0, 20. We know that is the y-intercept. The y-intercept is when the x value is 0. Where's y? It's at 20. So that's our y-intercept. So now we can apply this equation. So where is the stone 1 second into the drop? Well, 1 second, I can put that in for x. So 1 times -5, -5. -5 plus 20, it's going to be at 15 feet from the water. It's going to be 15 feet above the water. Where is the stone 6 seconds into the drop? What does this mean in real world terms? Well, if I were to put 6 in here, 6 times x, or I'm sorry, 6 is x, so 6 times -5, well, that's -30. -30 plus 20, that's -10 feet below the water. So yes, the rock can continue below the water. It can keep going. It's sinking, okay? If the bottom of the lake is 20 feet deep, how long will it take the rock to hit bottom, assuming its rate of fall does not change? Well, let's plug that in. So what is 20 feet deep? Well, technically that is -20. And what does that value represent? Well, that represents our y value, our f of x. So -20 equals -5x plus 20. And now I can add, or I can subtract 20 from both sides, so I get -40. is equal to negative 5x. Divide by negative 5 on both sides, and I get x is equal to 8 seconds. So it would take 8 seconds to get to the bottom. Oh, sorry, there we go. We can see it all. It would take 8 seconds to get to the bottom.